Hello everyone, in this video we are going to discuss this problem C2 Pokemon Army hard version of the Codeforces round 672 div 2. So the problem is we are given n integers which are distinct, which is AI, and then we have to select k indexes, that is we have to select a non-empty subsequence of those of that given sequence which with indexes like b1, b2 up to bk in such a way that our subsequence will be AB1, AB2, ABK, and then we have to choose that subsequence which have this value which is called the strength to be the maximum value, that is, and then we have to print that maximum value as well, that is AB1 minus AB2 plus AB3 minus AB4, that is the sum of the alternating sum of the element of the subsequence with sign plus and minus and all the way up to AK, right? So, and after that what we have to do is like we will do q operations. In the ith operation of that q operations we will swap the element al and ar, and after that we have to again print this value of the strength of the optimal subsequence, that is the value of the strength will correspond, the maximum value of the strength will correspond to the optimal subsequence. So now let us try to understand this problem in the whiteboard. So here we are given the sequence a1, a2 up to an. So now let us try to focus our attention on the subsequence because that is the most important thing. So now the subsequence, let us say that their indexes are ai1 and then ai2 and then ai3, ai4, all the way up to aik. Sorry for my awful try. And then all the way up to aik. So how and what will be the value of the strength if we choose this subsequence? So we'll add plus and minus to the answer to the values of the subsequence, and what will be the, it will, if our subsequence has length k which is odd, then this will add plus, that is if this has even then it will add minus, so this will be like plus minus 1 raised to power k plus 1. You can check this one. So this is the value of the strength, this is the value of the strength which we have to maximize and we have to print as our answer. So now let us focus our attention on any two consecutive element with plus minus sign for understanding. So let us say we take this ai1 and ai2. So now what how we should pick ai1 and how we should pick ai2. We should try to understand this thing, that we should choose always the consecutive elements with a positive difference, because if the difference is negative we should not take that pair and then instead output the rest as the answer. So we should always take the consecutive elements with a positive difference. Also we should always take the consecutive element with the maximum possible difference that we can get. And now how will we can maximize the consecutive elements difference? So let us try to understand this by seeing at the neighbors of ai1 and ai2. So the neighbors of ai1 will be ai1 and then ai1 plus 1 and then ai1 minus 1, and the neighbors of ai2 will be ai2 minus 1 and ai2 plus 1, right? So let us write this quickly. ai2 plus 1 and then ai2 minus 1. So now what is the property of ai1 such that it will give the difference to be maximum? So the property is that ai1 should be strictly greater than ai1 minus 1, and also it is strictly greater than its left and right neighbor. Similarly ai2 should be strictly less than its left and right neighbor, because if ai1 is not strict, if ai1 is, let us say if it is strictly greater than, and if we pick ai1 minus 1 then the difference will get less. So we should pick only that element which can give this first value to be maximum and the second value to be minimum among its neighbor. And why it's so? Like, let us say it is not like this, that is ai1 is not strictly greater than its neighbor, then we should not choose ai1, that is the argument, right? So let us say this is not like this, and instead this is like this, that is ai1 is 1 plus 1 is greater than ai1 and is also a greater than ai minus 1. So we should not pick then AI1, because if we pick AI1, then it's better to pick AI1 1 plus 1, because it's more than that, and that will give more to our first element's difference. So we should pick rather than AI1 plus 1, and then we'll check what is the property of its right neighbor, that is AI1 plus 2. So if AI1 plus 1 is greater than AI1 plus 2, then we should pick the AI1 1 plus 1 with a similar argument that is given earlier. So that is, it means that we should pick only those elements which is strictly greater than its neighbor at the first element of the consecutive elements, and we should pick the second element as that element which is strictly less than its neighbors. So we should check this condition, that if AI1 is that is this condition, we should check this, yeah, and also this, yep. So AI1 is, if AI1 is greater than AI1 plus 1, and AI it is strictly greater than its left and right neighbor, then what contribution it will add to our answer? So this will add AI1 plus to our answer. If AI2 is strictly less than AI2 minus 1 and strictly less than AI2 minus plus 1, so what contribution it will add to our answer? It will add minus times AI2, right, and so on. So now this is our check that we will do to check the contribution of any element AI1 to our answer. According to the contribution, we will pick the contribution if it is contributing. If it is not contributing, we will not pick the element. So in this way, before doing the query, we will do the check of all the n elements. So it will take order of n time for checking all the elements with this property, and we'll adding to our answer, which initially will be 0, right? After doing the queries, now when we do the queries, what will happen? So in the query, we know that we will swap AL and AR, right? So since we will swap AL and AR, we should try to understand this, that what elements will get affected when we will swap AL and AR. So the elements that will get affected are only the elements AL and AR and their left and right neighbors, right? AL minus 1 and AL plus 1, and similarly AR minus 1 and AR plus 1. So because they can contribute something to the answer, they might have contributed something to the answer which have calculated before the query, and now when we are swapping, that contribution will get lost. So what we have to do is, like, we have to subtract the contribution of all these three elements from our answer if they are contributing anything, that we will check using this constant operation check, right? And similarly, we will also subtract the contribution of AR minus 1 and AR plus 1. We will subtract that contribution minus from our answer, and after that what we will do, we will swap the element AR corresponding to AR, we will put AR, and then corresponding to AR we will put AL, and then we'll again add the contribution of all the three elements from our answer, and then we'll update the answer. So this operation of checking and subtracting the contribution, and checking and adding and subtracting and checking and adding the contribution will take constant time using this check and add. So in a way, we are doing constant operation per query, so it will take order of q time for each for doing the queries. So the total time complexity will be order of n plus q. So now let us look at the code to understand this a little bit better. So this is the code. We are doing the input n and q. Now initially, because we have to do the check, we have to check whether the element is greater than its left and right. So what we will do, we will append 0 to the left and the right of the array, so that we can do that checking easily. It will not affect the answer. So what we will do is, initially the answer will be 0. So what we will do, for each element, we will do this processing of n elements, and we'll check this using this add operation. We'll check that whether it's contributing plus or minus or not contributing at all. So what this operation add does is, it at index x, it checks that whether the index ax is greater than ax minus 1 and also greater than ax plus 1. If it is greater than, so it will add ax times c to the answer. Initially we will put c equal to 1, because we have to put the put the contribution before. We have to put the contribution of this element, which would be plus 1 times ax, that is the value of the strength. And similarly, if ax is less than ax minus 1, and similarly, and also ax is less than ax plus 1, then it will subtract minus 1 ax times c, which will be 1. So it will add minus ax to the answer, which we have discussed this already in the definition of the strength. So now when we do the query, what we have to do is we have to go one step to the left and one step to the right of L and do minus 1. Minus 1 will make ensure that it is subtracting the contribution of AL plus I, if any. And similarly, we have to check this condition that whether the right border, whether any of the element of the right border is strictly greater than L plus 1 times the left border, then we have to also subtract the contribution of R plus I. That is like, this is because that the border of AR, the left border and the right border, it should be strictly greater than the L plus 1, that is the right border of AR. Then only we have to subtract the contribution, because if they are intersecting, then we have already subtracted the contribution by doing it on the AL. So that's why we have checked this thing, that whether the right border is right, any of the right border is greater than L plus 1, then we will subtract the contribution like minus 1. And after that we will swap the elements, and then we will go to the left and plus 1, and also to the L element, and also to the plus and the right of the L element. We will add their contribution, if any contribution they are doing this check. And also if right border is not intersecting, it is greater than, strictly greater than L plus 1, then we'll also add the contribution of right element and will output the answer. And this is the base condition, is also the another base condition, that if, let us say, our left is first, then when we'll go to the left, then what will happen, that x will become 0, because we are outputting elements from 1, so the x will be 0 then. Similarly, if x will be n plus 1, then we will not do anything, because those elements are not there, they are 0, they will remain 0 all the time. So this is the way we will do this. I hope you understand this. So with that note, let us terminate now.